Hello students, welcome to the Turito School Foundation program. Today we are going to deal the very important topic, that is equations of motion and related problems. We would like to go for that special cases. For the 8th class we would like to go for that. Yes, we have to look equations of motion related problems. This is very clear, we would like to go for that. So, if you are going to describe the motion of a body with respect to that its position and its direction and its speed and the rate of change of the parameters, we would like to discuss in that one, right. Yes, you may have that different parameters regarding to that motion for a one particle or one object. So, with respect to the time, its position is going to be changed. Let us assume, yeah, we may derive the relations among the parameters, that is from u, v, a, t and s for the moving particle, where the notations are, yeah, you have to take that, where the notations are used as, we have to take that, that is in case of that uniform acceleration, yeah, we would like to confirm this equation, that is v is equal to u plus at. We would like to go for that. V is the final velocity, yeah, u is initial velocity and a is the acceleration and t is the time, right. We would like to go for that another equation, that is also s is equal to ut plus half at square, yeah. Just you can confirm the distance travelled by that body in a time, in a given time we would like to calculate. It may, whether it has been started from that rest position, we would like to go for that its initial velocity is equal to 0. It is very clear, we would like to go for that u is equal to 0, yeah. You have to take that or object started from rest, then we would like to consider its initial velocity u is equal to 0, no doubt at all. We would like to calculate that vertical displacement also, we have to use this one, horizontal and vertical. We would like to go for this, all right. Let us have that another one, you would like to go for that accelerated body which is going to be identified, it is very clear. Yes, you have to take that, this is going to be, yeah, it has been moving with that initial velocity, it is going to be final velocity, yes, yeah, we would like to go for that. So, it is very easy to solve this problem. You can apply this equation in case of the vertical displacement also. You have to take this one, that is you can go for that, yeah, v square minus u square is equal to 2as. Yes, you can apply this equation, it is very simple for you. If you are going to get that, yeah, at maximum height it is going to be v is equal to 0, it is very clear, and if you are going to get this one, a is equal to minus g and h is equal to h maximum. It is very clear, we would like to go for that one. So, you can easily find out that is equal to 2 into minus g into h maximum, it is very clear. So, h maximum is equal to u square by 2g, it is very clear. Yeah, we would like to go for that motion which has been restricted to move along vertical direction, that is going to be along y axis, we can confirm, yeah, the motion along one direction we can confirm. So, you can easily find out that maximum height reached by the body when it has been projected, yeah, it is the height which has been reached by that body where its final velocity, that is the terminal velocity, is going to be 0. It is very clear. We would like to confirm it is going to be here. Let us assume in case of motion in 1D, we would like to talk about that. So, we would like to get the motion in a one plane also, which is going to be having that angle of projection, right. Now, easily we will use this one, all right, it is very clear, right. With the help of this equation, yes, okay, with the help of this equation, we will calculate that time of ascent, time taken to reach the maximum height. It is very clear, we would like to go for this one. So, yeah, time of ascent, that is going to be Ta, that is equal to U by G. It is very clear, we would like to go for that, right. So, how you are going to get this one? U plus At, it is very clear, yeah, we would like to go for that. This is going to be 0 and U minus Gta, since at maximum height, yeah, we would like to get that maximum height, V is equal to 0 and A is equal to, we would like to go for that, this one, all right. So, we would like to go for this one, this is very clear, and we would like to get that time of ascent is equal to U by G, time taken by the body to reach the maximum height, and it is going to be time of ascent. So, we will apply this all equations to have the different parameters which are related to the a body which is projected vertically upwards from different positions, from a tower, or these are the different cases we would like to go for that, okay, all right, we can easily take that. So, if we are going to get this one, this is going to be average speed, we would like to take this one, yeah, you have to get that this is the average speed which is going to be identified, initial velocity and final velocity, we have to take that, right, yeah. Now, this is also one equation that can give the distance covered by the body in a particular second, it is one, yeah, you can take that n, that represents the time, yeah. If you are going to get that first or second or in a particular instant of time, you can calculate the distance covered by that body, it is very clear. So, we would like to get this one easily. So, let us have the look into another matter, that is, yeah, yes, in what way does you can use this one, this is very clear, you can easily find out that. So, what we have obtained by using this one, let us see, right. Yeah, we would like to find out that V minus U by A, that is equal to T, yeah, A is equal to V minus U by T, it is very clear, we would like to go for that. And also, if mass is going to be the constant, you can confirm this is going to identified, yes, you can get that F is equal to, we are having that ma, it is very clear. According to Newton's second law, just we are going to get that F is equal to rate of change of momentum. Change of P, momentum. Just we have to get this one, it is very easy for you. Yeah, it is very clear. So, F is equal to d by dt of P, that is going to be d by dt of mv, yeah, we can write down here. So, we would like to go for that m into d by dt of v, since m is constant. M is constant, that is going to be m into v minus u by t, that is very clear, right. That is going to be ma, we will get that, yeah. Here you can have this equation and you can substitute, that is going to be m1. So, that is equal to rate of change of momentum also, you would like to confirm this one. It's very clear. Okay, we would like to go for that some application part which is going to be discussed, that is external force acting on the body, that is equal to the rate of change of momentum. It is very clear. We would like to convey that Newton's second law in another form. So, the external force acting on the body, that is equal to that rate of change of momentum. It is very clear. You would like to rate of change, that is going to be represented as d by dt of p. It is very clear. Now, we would like to go for that. This is going to be mv, p is equal to mv, m is constant, will keep outside, that is better. Yeah, therefore, m into d by dt of v, rate of change of that velocity, it is going to be identified. Yeah, we would like to go for this one. Okay. Yeah, let us go for another one. With the help of this one also, we would like to calculate the distance travelled by the body in time in a particular interval of the time. We can easily find out this one. It is very clear. If it is going to be allowed to fall down in body which is going to be fall down, so you can measure that the distance travelled by that body. Yeah, this is going to be, yeah, you will find out that t minus 1 second also. It is very clear. This is going to be the last one. Yeah, easily you will get that. If it has been started from the rest, you will find out that yes, that is equal to, very clear, we will get that s is equal to ut plus half g t square. Yeah, sometimes in t minus 1 second, we would like to go for, in the last 1 second before reaching the ground, we would like to go for this one, that is g into t minus 1 whole square. So, yeah, we would like to get this one. This is the distance travelled by that body in the last second, that is very clear. Right, let us go for that another equation. This is also useful to solve the problems. Yeah, right. Now, let us go for that another one. Yes, we would like to go for this equation at a particular, when a body which is going to be covered that in a particular time, it is going to have the relation, that is yes n that represents the time. If you want to get that distance covered by that body in a particular time, just we can go for that S1, S2, S3. Yeah, it is very easy for you. Yes. From, if you are going to get that a body which has been started from that rest position, we would like to go for, this is going to be 0 and S, it is going to be t square. It is very clear, we would like to get that in case of uniform motion. Yes. So, we can have the different applications. Yes. So, finally, we are all going to have that all the equations of motions at your glance, just you can have the observation, right. Yes, in case of freely falling body, we would like to go for that. What happened? Let us see that. Yeah, in case of freely falling body, we would like to go for that. It is u is equal to 0, a is equal to plus g. So, that equations are going to be, yeah, yes, it has been started from the rest. You can take that from the rest position, all right. It is very clear, we would like to go for this all equations. So, A is equal to just is going to reach the ground. Very clear, you would like to go for these equations and we can solve the problems, different problems associated with this one. Yes, if they are going to be having that some boundary conditions on that equation of motion regarding to that vertical displacement or vertical distance travelled by that body when it is allowed to fall down freely. It is very clear. Vertically, just you have to take that equation of motion for that a body projected vertically down. It is very clear. We would like to go for this one. It is easy to solve the problem. While you are going to get that projected vertically in upward direction, it is projected with some initial velocity. Just we have to take that u is that initial velocity, and a is going to be minus g. Yeah, it is going to be projected with that velocity. It is very clear. We would like to go for that. It is u is not equal to 0. It is having some initial velocity. At the same time, does it has been reached that maximum height, you have to define that it is v is equal to 0, that is going to be vf. We can denote it as final velocity of that body which is going to be projected is 0, that is the height, maximum height reached by the body from the ground. It is very clear. So, we can have that different cases, all right. Yes, it is a very simple problem. Based on that, a ball is dropped from the tower, it is very clear, all right. The distance travelled by that ball in the last second is 40 meter, all right, it is very clear, okay. Find the height of the tower, you have to get this one. In this case, you have to solve the problem, yes. With the help of the equations of motion, just you have to solve this problem. This is very clear. A ball is dropped from a tower, it is very clear. You have to take this one, right, from the top of a tower. The distance travelled by the ball in the last second is going to be 40 meter, it is very clear. Yes, you have to take that. Yeah, this is the top of tower. It is going to be ground. So, h is the height, that is going to be the vertical distance which has been covered by that body, all right. So, we would like to consider that u is equal to 0, all right, it is going to be 0, right. So, you have taken that, it is going to be in the last second it has been covered 40 meter, right. Okay. We would like to go for this problem to solve that height of the tower. Very clear, if you know that vertical distance which has been covered by that body in a particular time, then it is easy to solve the problem. If you know the distance and time, easily you will solve the problem. It is very clear for you. How it is possible? Let us see. By knowing the equation of motion, just we have to get this one, that is going to be S is equal to ut plus half at square. This is very clear, you would like to know about this one, right. Now, you are going to have that u is equal to 0, very clear, and S is equal to h, let us assume, yeah, A is equal to G, it is very clear. Okay, these are all the considerations, all right. Okay, the total height, it is going to be the total vertical distance which has been travelled by the body, which is allowed to fall down. Yeah, that simply it has been dropped from a particular height. The time, the total time taken by that ball to reach the ground is going to be the t seconds, but in t minus 1 seconds it has been travelled the distance. Let us have a look. That is going to be h is equal to 0 into t plus 1 by 2 into g t square. It is very clear. We would like to go for this one, right. So, let us have that first equation, that is half g t square. This is the first equation. Very clear, we would like to go for this one. After that, if you are going to get this one, yes, Yeah, this is we would like to get this one. Let us have look. If we are going to identify this one, this distance, that is h minus 40. It is very clear. All right. So, this is going to be h minus 40. It has been covered in the duration of the time, that is going to be t minus 1 seconds, very clear. All right, we would like to get this one. Now, we will apply that equation, that is very clear. Therefore, h minus 40, because it has given in the last second, it has that 40, it has covered the 40 meter vertical distance. All right. So, we would like to go for this distance. This is going to be the h minus 40 in the time interval of, in the time duration of t minus 1 seconds, it is very clear. So, in t seconds it has been travelled the h distance, vertical distance. In t minus 1 seconds it is going to be having the vertical distance, that is h minus 40, it is very clear. We will apply that equation of motion, it is very clear for you. Therefore, h minus, we would like to go for the, yes, let us have the look, that is going to be h minus 40 is equal to yeah, that is 0 plus 1 by 2 into g into t minus 1 whole square. It is very clear. We have to take that ut, it is going to be ut, that is going to be 0, no doubt at all, right. So, h minus 40 is equal to 1 by 2 g t minus 1 whole square. It is very clear. We would like to go for this one. Right. So, this is equation number 2. Is it possible to solve the equation 1 and 2 to get the height h? That is, if you want to get the height of the tower, you have to solve that equation 1, this is equation 1 and equation 2, easily we will get that. And you can substitute in that equation to solve for that h, it is very clear. Let us have the look. Okay, right. So, we would like to go for this equation solvation, that is yeah, equation 1 minus equation 2, does it gives, yeah, we would like to go for that, that is, yes, you have to get this one, that is h is equal to half gt square, it is very clear. You would like to go for that. H minus 40 is equal to 1 by 2 g into t minus 1 whole square, it is very clear. We would like to get that, that is 1 by 2 into g t square plus 1 minus 2t, yeah, it is very clear, h minus 40, right. Okay. Let us erase some part to have that. Okay, you can get this one. We have to consider g is equal to 10 meter per second square, it is very clear. Therefore, you will get that h is equal to, right, you know very well about that, h is equal to 1 by 2 g t square and h minus 40 is equal to 1 by 2 g t square plus 1 by 2 g minus gt, it is very clear. If you are getting that minus, yeah, we are going to get that subtraction, all right. Okay, let us have that. Yeah, h minus h plus 40, you can get this one, that is equal to, you will get that, yeah, you will get that it is going to be cancelled, and 1 by 2 g t square minus 1 by 2 g t square minus 1 by 2 g plus g t. It is very clear, we can get this equation, all right. Easily we will solve this problem by applying that subtraction method, all right. Okay, let us have the look. You can cancel that, these two terms, yes, right. So, 40 is equal to, that is going to be 1 by 2 into minus 1 by 2 into 10 plus 10t. It is very clear, you will get that. So, 45 is equal to 10t, t is equal to, you will get that 4.5 seconds. It is very clear. After getting that t value, you can easily solve the problem, all right. So, if you are going to have the substitution in this equation, you can easily solve the matter, all right. Let us have the look to have the substitution, that is, if you want to get that yeah, you have to use this space, that is h is equal to 1 by 2 into 10 into, that is 4.5 into 4.5. Let us have the simple calculation. Yes, you can use this equation 1 to get that h value, it is very clear. So, you will multiply this one and you will get this value. Yeah, if you are going to have this value, let us see. Therefore, h is equal to, that is 5 into 25, 22. Yeah, if you are going to get this one, that is 2, just 20.25, yes, it is very clear, 20.25 into 5. So, you will get that, yeah, you will get that 101, yes, you will get that 101.25 meter, easily you will get that. Everyone has to look into that matter what we have been solved. If you wants to get that h value, we have been taken that two equations, that is first one is h, yeah, we are having that equation of motion, that is going to be the h is equal to 1 by 2 gt square, that is very simple, we have been taken. After that we would like to go for that, in the last second the distance travelled by that ball they have given, all right, in the last second it has given. Okay, now if you wants to get that in t minus 1 second the distance travelled by that ball, which is going to be that h minus 40, yes. So, we would like to have this equation and method of simplification, we are all getting this one by doing all the calculations. Okay, you have been considered that u is equal to 0, which has been started from that rest position, it is allowed to fall down, right, and we have taken that g, and it is very clear we would like to go for this h and h minus 10, h minus 10, h minus 40 is the distance travelled by the ball in t minus 1 second, it is very clear, all right. After that you can go for that equation, this is going to be that equation we have been subtracted, we have been taken, yes, after the subtraction it is going to be changed, yeah, it is very clear, we would like to go for this one. You know very well about all these methods and having the calculations, we can easily solve this problem. After getting that t, you can substitute any of the equation, you will get that h value. After knowing the t value, you have been substituted the t, that is h is equal to 1 by 2 gt square. You have to get that value. Initially you have to get that 4.45, 4.5 and 4.5 multiplication, then you will go for that further multiplication. Easily you can do that, 101.25 centimeter, 25 meters, very clear. So it is going to be 101.25. Yes, right. Okay, let us go for another problem. Yes, you can take that. A stone thrown up with a speed u from the top of a tower reaches the ground, it is very clear, reaches with a velocity 3u, it is very clear. The height of the tower is, you have to take this one, right. Now if you are going to identify that the given data, you can apply that. Right, you will take that you have to apply that v square minus u square is equal to 2as, it is very clear. Let us assume it is going to be you can take that a ball thrown up with a upward with a speed of u from the tower, it reaches the ground, it is found to be velocity. So by getting that, you will get here v is equal to 3u, let us assume, okay, and u is equal to, you are getting that u is equal to u, what we are going to get this one, it is minus u. If it is going to be taken that thrown up with a speed u from the top of tower, we are going to consider this one, that is very clear, right. We would like to go for this one, that is and we can take that, so we have to get this one, nine u square, that is equal to u square, very clear. Now you will get that, that is we can get this one, right. Now if you are going to apply this equation, we can easily solve that one, all right. We would like to go for this one, that is 9 u square minus u square is equal to 2 g h, it is going to be, it is 8 u square by g is equal to 2 h. So you will get that 4, that is going to be 4 u square by g, that is equal to h. Yes, this is very clear, we can go for this one, right. Okay, so let us have the look into that matter, we can easily solve the problem, right. A body starts from rest, all right, and then moves with a uniform acceleration. Then what you can say about this one? You have to look into that matter, everyone has to look into that matter, you have to go for that. If your body which is going to be projected, we would like to go for that, its displacement is directly proportional to the square of the time, it is very clear. A body starts from rest, it is very clear, you have to take that, it's u is equal to 0, right, and then moves with uniform acceleration, that is very clear, you can identify that. Yes. So A is uniform. If you know that S is equal to ut plus half at square, this is very clear, we would like to go for that. all right. Now, we are going to get this one, that is 0 into t plus 1 by 2 into g t square. So, S is going to depend on t square, all right, it is very clear, we would like to go for that. Its displacement is directly proportional to the square of the time, it is very clear. So, t is the time. Let's, if you are going to get that in case of 1D, yeah, it always moves in straight line, it is very clear. If it is moving in the straight line, yes. So, distance and displacement is going to be displacement, yeah, and distance travelled. Both are going to be equal, it is very clear. So, from that one we can conclude that matter, its displacement is directly proportional to the square of the time, it is very clear. Always moves in a straight line, this is also going to be the correct, it is very clear. From all these things we can confirm, right. Okay, let us have that another one. Yeah, we would like to go for this one. A particle covers half of the circle of the radius, or this is a general and standard question. So, then the displacement and distance of the particle are, we had to, right, let us go for that. Yeah, a particle covers the half of the radius of the circle, just we have to take that. We would like to go for this one. Yes, we would like to go for that. Yeah. Yes. Yes, we would like to go for that. If we are going to get that center, A and B, this is going to be, R is the radius, let us assume R is going to be the radius, it is very clear. Yes, if you are going to take that, this is going to be that A plus B, yeah, sorry, A, very clear, we would like to, displacement is nothing but the shortest path. So, AB is equal to R plus R, that is going to be the displacement, very clear, we would like to go for that, all right. So, distance covered by that body which is going to be identified, it is very clear, yeah, 2 pi R by 2, that is distance covered, it is going to be distance. So, pi R. So, you can confirm this is going to be, yes, 2R and this is 1. Okay students, we can go for that different model questions in this one, right. We would like to go for that 2R and pi R, all these are the correct answers. Okay students, let us have that another sessions in the coming classes. Thank you very much, have a nice day, keep watching.